Don't you just hate those situations when you need some coffee and it takes a while for you to manually use this in the morning or at your job site? Maybe at a local restaurant or a fast food place, you're trying to get your coffee. But quite a bit of that manual labor is difficult in the morning. Pumping this lever back and forth 6 or 7 times can wreak havoc on a morning in which you hope is the best day of your life. Probably an exaggeration. Anyway, welcome to the automated pumper. Under $15, I will show you how to use a standard air pump available at your local Walmart, some tubing, about $2 for 3 meters, and a heck of a lot of hot glue gun to make this. An automated pumper easily fills up your cup in about 15 seconds. Water, tea, any fluids you like, and voila! You can fill it up without any manual labor. Guaranteed. Ugh. That's some nasty water. Okay, so this is the top of it. This is the handles that just grip onto the sides so the top stays put. And we have just a simple hinge mechanism there. The handle is here, and this little tab allows you to raise this up slightly, push down, and close it. So if you're transporting it, whether it's full or empty, the handle doesn't get stuck. Yeah. So let's open it up and take a look what's inside. Okay, looks like it's just some simple. Looks like it's just some simple. Oh, that's not terribly bad. We have the spring mechanism. There it is. I'll just keep that there so I don't lose the parts. I have just the standard spring mechanism, just a spring and 2 hooks. Straightforward. Here's the plastic lever that is pushed against this diaphragm, right? That's pushed against this diaphragm right here. And what we have here is this would be the bottom part. Where the fluid is contained. This would be locked into place, and that lever would push down onto this supposed diaphragm here. I think one of the big reasons why this is not working as good as if it was brand new is this rubberized nipple right here has worn down. And as a result, when this is placed against, when that rubber nipple is placed against this area right here, which is where it rests, quite a bit of air is leaking out. So it wouldn't be, I suppose, terribly difficult to fix that, but then I wouldn't have a project to do, and where's the fun in that? I need to test which one of these air pumps will best perform in this, for this particular job. I don't want to wait 5 or 6 minutes for water to be exerted out. So I'm simply going to, let's see here, where is it? I'm going to put this back here. This is the nozzle, and then I've got some standard tubing, same place that I received this aquarium air pump. So all I'm going to do is, I'm going to try the little one first. Let me plug this in real quick. Okay, so I have this plugged in right now. It's producing quite a stream of air. Can you see it? And I can feel it. It's not all that impressive. Seems very little to me, but that's why I got 2. I didn't know quite which one would work best for this particular project. So there we have some action right here. We should expect this air pump to perform quite a bit better just because it's designed for larger capacity of air to move, since it is designed for a larger tank. So I'm going to set this right back the way I had the other one, keep the test the same, that way there's no or very little variation between the tests, so we can compare the performance. And I'm going to do the exact same thing. I'm going to just lick my finger to make sure that that's as sealed as possible. I'm just going to hold it there and let's see if we notice a difference. So there was definitely quite a bit of difference between the two. This 10 to 30 gallon air pump performed better, so I think we're going to use this. Let's take a look inside of it and see if we can configure this to fit into the top of this. So I'll just move these here. Oh, that is not what I expected at all. See if we can get a good shot of this. This looks like, oh man, well, that's going to be an interesting challenge. It looks like what they've done is they've taken a transformer and made this basically act like a magnet, with a magnet attached to this lever, which is pumping air in this diaphragm and then out the outlet there. You can hear that. So this is actually a fairly creative process because it removes the AC to DC converter as well as removes the necessary motor, because you can have basically a transformer operating as the power, the transformer, as well as the AC to DC, because you don't need the DC any longer. You can just use one basic tool that's introducing the mechanism because of this magnet here. And I was really hoping to avoid was portability. I was really against using the plug-in. However, I don't have one that is strictly DC that I can power up with a couple batteries, so we're going to just have to make do with what we have. That's just kind of part of doing these projects. You get to play with parts, but you have to contend with challenges. So I'm going to go ahead, including design changes. So I'm going to go ahead and I'll have this somehow installed in this top here, and I'll make a place for this. Okay, so looks like what we have here is this line, which is what we needed to create. So let's see how well this fits in here. So the idea here would be that we take this, slides into this opening there, which looks like that fits just well, and there we go. So it's countersinked quite a bit down, so we should be able to put the top on and not run into any issues. And as we can observe, I have the top on, and there's definitely plenty of room, so that's not going to interfere with the top design. Okay, so I went ahead and installed this bottom piece here with one of the best tools available just about at any hardware store, hot gun. So I went ahead and put quite a bit around the bottom here and through that hole that I created earlier in this, and that proved to actually be pretty beneficial to actually strengthen this quite a bit up. So that's that hole is actually protruding. It's actually protruding right through here, and that it's really helped to give it quite a bit of strength. So now this glue will help in reducing the vibration, but this center plastic piece that's part of the housing will actually help the vibration as well. It'll take some of the stress out of it. And let's see if we can see. You can probably see pretty clearly that I've also put a fair amount of hot glue there, and that's just drying right now. Did the same thing on the other side. Feeling pretty sturdy. I mean, I can lift it up, and I'm really moving it pretty hard. So once that dries, I think that'll be pretty adequate for this particular project. I also have now made some room, just kind of etched out an area with my Dremel for the standard plug in there. See if we can get a good, there we go, for the plug in there. And so now we can plug this in and out without having a wire permanently attached. This will be handy just if you want to travel. And I just want to, I just want to unplug the wire and be done with it. I don't want to always have a wire connected to this top. This way that eliminates the need for that. So I'm pretty happy that I had an extra part there. The reason why I did end up getting two is because I didn't know if maybe the metal handle was going to push one of these down, depending on where I placed it. I was afraid that if it would just rested on this, it might rest halfway down, and it would be too easy for that thing to accidentally turn on. In this case, happily that wasn't an issue. I was going to install this switch here. I would have been happy to install this just because I had it in my toolbox, and I had to actually go to Radio Shack to purchase these other ones. So that was kind of unfortunate. When a project like this I want to get done, reasonably fast. I want it to be a day project. However, the challenge with this switch is it's single pull, single throw, but it isn't momentary. And so I could accidentally leave the pump on and it starts to overflow, and that's going to be an issue. So I just need to press down a little bit on here and this momentary switch actually activates. There it is, fully installed. And I haven't heat shrink these yet, but as you can see, I have just going from the plug-in that I installed earlier. So it's just going straight into this transformer. From there, it's just going to the switch from the single pull, single throw momentary switch. It's just going right back. So I'm going to heat shrink this, and then I'll be on to the next phase, which is connecting this to the other side of the port, to the other side of the top. So I'll go ahead and work on that, and I'll shrink this up. The amount of volume that is pumped with this diaphragm should basically show how much water or fluid, whatever you have in there, should come out. And it should displace the same amount of volume. However, it didn't quite work well due to the seal. So we're going to be able to avoid most of that by using the electric pump. However, what I'm after is the diameter of this seems to be just enough to be airtight through this. So that connects there airtight just fine. But also the interior diameter seems to be just perfect to make this through here. So I'm thinking that this might be the way to go. I might seal that a little bit later with some caulking or something, but as a good test, this seems to be work well, and it fits right in, it's centered, and I'll just cut a larger piece out of this so that way it lies flat on either side, and I'm just going to go with this for right now, see how this operates. We've got the top here. I didn't, of course, put any glue on this because that's going to be inserted into the nipple on the other side. And I basically used a hot glue gun action here. It melted part of the hose with this, and it binded very strongly to this top. So I don't believe there's going to be any leakage because I sealed it quite clearly all the way around with a hot glue gun. And it actually melted some of this, as you might expect. So now I know that it's not going to slip. So now I'm going to hook it up and test it. This protrudes just a little bit, but that's not going to be an issue because once this is inserted to this guy here, it's not going to come through that. So that's not going to be an issue. There we go. So that's, as you can see very clearly, it doesn't protrude out, so it's not going to, mess with the liquid at all. And on this back side here, it's now pretty evident that this should work pretty well. And very good. And of course this large surface area now will prevent that smaller piece from just being popped right in over the long run. So let me see if I can get this top on, and then that should be it, really. That's all the magic that we need to perform to get this to work. So hopefully I've done everything correct, and I should be able to just snap this right back in. Again, and it's of course nice when you're doing a project to have as much of the attachments off as you need. So without further ado, there's that, in case we need to get a little closer. And for those that don't know, I had to actually switch the switch that I had on here. This is the larger single pull, single throw, because by default the other switch was true, or it was on. So it was basically the reverse operation. I would press down and it would turn off. I would release and it would stay on, which is the opposite of what we want. And so I went ahead and just switched it to a larger switch. The wiring and everything else is going to be exactly the same. Nothing different in that. So let's hook it up. I think I got this snapped in there. Move this back a bit. Just plug that right in there. And I'm going to just take glass here and da-da-da. Let's see what it looks like. I'm going to zoom in. Okay, let's see. This is clear water, so I apologize if it's not very visible. But all you need to do is just tap it lightly, and there you go. Fills right up. Pretty impressed with the speed. It's not too bad. Of course, it could be a bit faster. However, if you take a look at it from the side, you'll likely notice that it goes straight down. If it had been going real slow, this would have been angled my way. And if it goes too fast, it's going to angle forward quite a bit because of the way this nozzle is, and that may cause problems down the road. So I think a full-size cup there is, you know, I don't know, was that 10 seconds max? So overall, I'd have to say I'm absolutely pleased with it. It works very well. I'm going to continue to use this for several months. I don't foresee any problems with it. I think it's built pretty well. The only thing that I'd have to maybe have a little bit of concern about is moisture may get around the perimeter right here between the top and the casing side. However, a little bit of caulking, which I'll probably apply when I have some free time, will solve it. That'll just prevent a little bit of moisture to come in. Otherwise, you know, I think this is a really fun project. It took me about half a day to kind of figure it out, test which pump would work, install it, go through the challenge of making sure that it would easily go through the challenge and make sure. I don't know why they're counting down. I mean, that the card is full.